Let's take a look at exponent properties. Now I'm going to list just a few of them down here. Our first one we'll take a look at is if you have x to a power, like x to the m, times x to a power, x to the n, then you add the exponents. So that'd be x to the m plus n. Our second one, if you're taking x to a power and you're raising it to another power, then you multiply the exponents together. If you have x to a power over x to a power, then you subtract the exponents. So you got x to the m minus n. Now there's an easier way that I usually cover than showing that one. And I don't really like this next one, but you see it in some different books, and it's in different forms even. But if you have x to a power, and then you have like y to a power, and you raise it to another power, then this becomes x to the m times p and y to the n times p. Now, we're going to talk more about this one. I don't really like seeing that formula. There's a much easier way to think of this, and it works all the time. This gets you thinking that you're just going to have x to a power and y to a power raised to a power. Not all books do that, but I've seen that before. And if you got something to the 0 power, that's always equal to 1. Now, someone's dealing with negative exponents, and I like to put numbers here because I think it clicks better with students. Let's say we got x to negative 2. Well, we're going to put this in fraction form. You can always create a fraction by putting it over 1. We don't want negative exponents. We can get rid of negative exponents by taking them opposite of where they're at in a fraction. So this x to negative 2 we can take downstairs to the denominator, and it'll become x to the positive 2. And then we always have a placeholder of 1 in the other location, assuming there's nothing else up there. Well, another one is if you have x to the, let's say, negative 3 down below in the denominator. Well, since this is already in fraction form, all I have to do is take the x to negative 3 and move it up on top. Again, you move it opposite where it's at in a fraction, and the sign of the exponent changes. So it becomes x to the positive 3 over 1, which then would just give you x to the third. And one last one. If you have a fraction to a negative power, say negative 2, then you take the reciprocal of the fraction, flip the fraction, becomes y over x, and the sign of your exponent becomes positive. And then you could take that to the second power and take this to the second power. So you'd have y squared over x squared. Now those are our basic properties. Like I say, we'll look at some variations of these. You have some real oddball ones that occur every now and then, but those are your basic ones. So let's look at our first problem. Some of these will be pretty short. We got x to the fifth times x squared. Now if you got x to a power times x to a power, you add the exponents. So we got 5 plus 2, which gives us x to the seventh. Now here we got y to the eighth times y. Now y doesn't have a power, but there's always an invisible 1 there. So if you don't got an exponent, you could always put a 1. So we got y to a power times y to a power. We add the exponents. That gives us y to the 8 plus 1. And 8 plus 1 gives us 9. So we got y to the ninth. Here we got negative x times negative x to the third power. Now, again, this doesn't have an exponent, but I could always put a 1 there. It doesn't matter what you're dealing with. If you got negative x to a power times negative x to a power, as long as these are the same, then you can add the exponents. So that'll become negative x to the 1 plus 3, which gives you a negative x to the fourth power. And anytime you're taking a negative to an even power, then it becomes positive. So this is going to become x to the fourth. And that's our answer. Now here we got 2 to the third power raised to the second power. When you're raising one exponent to another exponent, you multiply the exponents. So we're going to have 2 to the 3 times 2 power, which is 2 to the 6, which gives us 64. If you take 2 times itself 6 times, you get 64. Okay, let's look at this one. We got negative x to the third power, all of it raised to the fifth power. Well, again, we're raising an exponent to another exponent. So we're going to have negative x to the 3 times 5. Again, when you're raising one exponent to another exponent, you multiply them together, which gives us negative x to the 15th power. Now, when you're taking a negative whatever, negative number, negative variable, negative whatever, to an odd power, it stays negative. And this is just x to the 15th. So that's negative x to the 15th is our answer. Now, if that had been even, if it had been 14, for example, then this would have been a positive x. So it would have been x to the 14th. Okay. Pretty soon we'll get in some of the interesting ones. Here we got k to the 4th to the 5th power. Again, you're raising one exponent to another exponent. You multiply them together. So 4 times 5, that gives us k to the 20th power. Okay, here's the one I want to get down to. We got 3y to the 5th raised to the second power. I almost think it should be called the distributive property of exponents. Maybe even my name on it. I don't know why they didn't give it that. But if everything inside of your parentheses is either multiplication or division, and you're raising it to a power, then you can take everything to that power. So we can take the 3 to the second power, and we can take the y to the 5th to the second power. So that's going to give us 3 to the second power, and y to the 5th to the second power. Well, 3 squared is 9. And remember, when you raise one exponent to another exponent, you multiply them together. 5 times 2 is 10. So we got y to the 10th. So our answer is 9y to the 10th. Now, the reason why I never have liked this property up here is same idea. If everything inside of your parentheses is either multiplication or division, then you can take everything to that power. But this gets you limited, thinking you just 2 items in here. But it doesn't have to be. You could have 5 items multiplied together. Just as long as everything's multiplication or division, you can apply that property. We'll go ahead and start a new page. And we'll look at number 8. Okay. So we got 3/5 x to the 3rd raised to the second power. Okay. Now, everything inside of our parentheses is either multiplication or division. We got 3 divided by 5 times x to the 3rd. So everything's multiplication or division. So we can apply that idea. Distributive property type idea. We're going to take the 3 to the second power. We'll take the x to the 3rd to the second power. And we'll take the 5 to the second power. So I got 3 squared over 5 squared. And then x to the 3rd squared. Well, 3 squared is 9, 5 squared is 25, and raise an exponent to another exponent, you multiply the exponents. 3 times 2 gives you 6. So our answer is 9/25 x to the 6. Take a look at this one. We got negative 3, m to the 4th, n to the 5th, raised to the 4th power. Notice everything inside is multiplication. Negative 3 times m to the 4th times n to the 5th. So that means we're going to take everything to the 4th power. It's kind of like a distributive property. So we're going to take negative 3 to the 4th power. We're going to take m to the 4th to the 4th power. We'll take n to the 5th to the 4th power. Well, negative 3 times negative 3 is 9, times another negative 3 is negative 27, times another negative 3 is 81. Now, when you're raising one exponent to another exponent, you multiply the exponents. So 4 times 4 gives us 16. And here, 5 times 4 would give us 20. So we got into the 20th. So our answer is 81, m to the 16th, into the 20th. Okay, let's look at this one. We've got negative 2, x, y to the 4th, raised to the 3rd power. I know it seems like I'm showing a lot of this type, but I just want to really emphasize that idea. If everything inside your parentheses is multiplication or division, then you can raise everything to that power. We got negative 2 times x times y to the 4th. So we can take the negative 2 to the 3rd power, the x to the 3rd power, and the y to the 4th 3rd power. So we're going to have negative 2 to the 3rd, we'll have x to the 3rd, and we'll have y to the 4th raised to the 3rd power. Negative 2 times negative 2 is 4, times another negative 2 is negative 8. X raised to the 3rd power is just x to the 3rd. And here we're raising one exponent to another exponent, we'll multiply them together. 4 times 3 is 12. So our answer is negative 8, x to the 3rd, y to the 12th. Now note, if you had something look like this, if you had this, I'm raising to the 3rd power. If everything inside your parentheses is multiplication division, you can take everything to that power. Notice here we have a minus. We have x minus 2. That does not fit what I've been saying. This does not equal x to the 3rd and minus 2 to the 3rd. A lot of people will make that mistake. This only applies if everything inside your parentheses is multiplication or division. Okay, let's look at this one. This gets into one of our properties I never really use. I like to think of it a different way. 12x. Now, first off, notice that we have an x here. If I were to put an exponent on it, it's like x to the 1st. Okay, now we want to simplify. 16 and 12, I think of the number divides into both of those. Well, 4 does. 16 divided by 4 is 4. 12 divided by 4 is 3. Now, when you have x to a power over x to a power, you're going to subtract the smaller exponent from the larger one. So 5 minus 1 gives us 4. And we're going to have x to this power, x to the 4th power, where our larger exponent was, which was up on top. And that's our answer. Let's take a look at this one. We got 12x squared over 9x to the 6. Okay, number-wise, 12 and 9, they're both divisible by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. Now we got x to a power over x to a power. So subtract the smaller exponent from the larger one. Mostly you do this in your head. But 6 minus 2 is 4. So we're going to have x to this power where our larger exponent was. And our larger exponent was down in the denominator this time. So we're going to have x to the 4th down here. And that's our answer. I don't like the formula where you just subtract the exponents without any kind of thought, because then you end up with negative exponents, and you have to worry about getting rid of those. So let's take a look at this one. We got negative 50, x to the 3rd, y to the 10th, over 10, x to the 8th, y squared. Okay, number-wise, 50 and 10, this negative stays here. 50 and 10 are both divisible by 10. 50 divided by 10 is 5. 10 divided by 10 is 1. Now x's. X to the 3rd over x to the 8th. So we're going to subtract smaller exponent from the larger one. 8 minus 3 is 5. So we'll have x to this power, x to the 5th power, where our larger exponent was, which was downstairs. Now for our y's. We got y to the 10th over y squared. Subtract smaller exponent from the larger one. 10 minus 2. Oops. 10 minus 2 gives you 8. And we're going to have y to this power where our larger exponent was, which was up on top. So we've got y to the 8th up there. Which gives us negative 5y to the 8th over x to the 5th as our answer. Excuse me. It looks like I'm about out of space, so let me go and start a new page. And let's look at number 14. We got negative x squared over y to the fourth raised to the third power. Okay, if everything inside of your parentheses is either multiplication or division, and you're raising it to a power, then you can take everything to that power. It's kind of like a distributive property. So I'm going to take the negative x squared to the third power, and I'll take the y to the fourth to the third power. So we're going to have negative x squared to the third power over y fourth to the third power. Now when you're taking a negative to an odd power, it stays negative, so that's going to remain. Now x squared to the third power. When you're raising one exponent to another exponent, you multiply them together. 2 times 3 is 6, so we got x to 6. Down below here, you're raising one exponent to another exponent, you multiply them together. 4 times 3 is 12. So our answer is negative x to 6 over y 12. Okay, let's take a look at this one. We got 3m to the third n over q to the fifth raised to the fourth power. Now notice, everything inside the parentheses is multiplication or division. 3 times m to the third times n divided by q to the fifth. If everything is multiplication or division, then, and you raise it to a power, you can take everything to that power. So we'll take 3 to the fourth power, the m to the third to the fourth power, the n to the fourth power, and a q to the fifth to the fourth power. So we got 3 to the fourth, we got m to the third to the fourth power. Let me write that a little bit more legible. There we go. And we got n to the fourth power over q to the fifth to the fourth power. Well, 3 to the fourth power, 3 times 3 is 9, times 3 is 27, times 3 is 81. When you're raising one exponent to another exponent, you multiply them together. 3 times 4 gives us m to the 12th, n to the 4th, over q to the, multiply the exponents, 5 times 4 is 20, q to the 20th. And that's our answer. Okay. Let's take a look at this one. We've got negative 3x to negative 4. We don't like negative exponents. So first thing I'm going to do is create a fraction. So I got negative 3x to the negative 4, and I'll put it over 1. You can always create a fraction by putting it over 1 if you don't already have one. Now how we get rid of a negative exponent is we take it opposite where it's at. So we're going to take this x to negative 4, and we're going to take it down to our denominator. Well, negative 3 remains up on top. When I take the x to negative 4 down below, it becomes x to the positive 4. So whenever you move anything opposite of where it's at in a fraction, the sign of the exponent changes. Now, the negative number doesn't bother us. We just don't want negative exponents. So that's our answer. Let's take a look at this one. We got negative 2 over 4x to the third raised to the negative 2 power. Now, right away, I noticed 2 and 4, I can reduce that. I'm not sure why I even threw that in. I expect when I made this problem up, I didn't even see that. They're divisible by 2, so it gives me negative 1 over 2x to the third raised to negative 2 power. Now, whenever you have a fraction to a negative power, you can flip your fraction, take a reciprocal of it. So that's 2x to the third over negative 1. And then the sign of your exponent becomes positive, so it becomes a positive 2. Well, everything inside is either multiplication or division. 2 times x to the third divided by negative 1. So we'll take everything to the second power. I could actually get rid of that negative 1 before I did this, but I'll go ahead and do it this way. I like the fact that it demonstrates multiple things being taken to the second power. So we're going to have 2 squared, we'll have x to the third squared, and we'll have negative 1 squared. Well, 2 squared is 4. When you're raising x to a power, you multiply the exponents. 3 times 2 is 6. So we got x is 6. And negative 1 squared is 1, which then just gives us 4x is 6. And that's our answer. Let me start a new page. What problem am I on? I'm ready for 18. We got 5 over x to negative 4. Now again, we do not like negative exponents. We want to get rid of them. So this x to negative 4, I'm going to move that up on top. When I move it up on top, it becomes x to the positive 4. And then I'll put a placeholder of 1 down below. But 5x to the 4th over 1 just gives you 5x to the 4th. And that's your answer. Now in this one, we got 3 over 5x squared to the negative 3rd power. Again, we don't want negative exponents, so this entire parentheses is to a negative power, so I'm going to take that entire thing and move it up on top. So that gives us 3 and then times 5x squared to the positive 3rd power over, I'll put a placeholder of 1 there, although that 1 doesn't do anything, so I can drop it. Well, I want to simplify this further. Notice everything inside of our parentheses is either multiplication or division. And we're raising it to a power, so I can take everything to the power. Take the 5 to the 3rd power and the x squared to the 3rd power. So 3's there, 5 to the 3rd, and x squared to the 3rd. Well, 5 to the 3rd, 5 times 5 is 25, times another 5 is 125. When you're x to a power, you're raising it to a power, you multiply the exponents. 2 times 3 gives us x to the 6. And that gives us 375 x to the 6 as our answer. Let's take a look at this one. 20x squared y to the negative 3 over 30 x to the negative 4 y to the negative 12. Lots of negative exponents. Okay, we don't like negative exponents. So I'm going to take this y to the negative 3, I'm going to take it downstairs. This y to the negative 12, I'll move it up on top. And this x to the negative 4, I'll move it up on top. Now again, when you move anything opposite of where it is in a fraction, the sign of the exponent changes. Now we didn't move the 20 or the x squared or the 30, so they remain as is. This x to the negative 4, I took it up on top to the numerator. It becomes x to the positive 4. This y to the negative 12, I moved it up on top. It becomes y to the positive 12. Now this y to the negative 3 I took down below, and it becomes y to the positive 3. Well, I can do a little bit of simplifying. 20 and 30 are both divisible by 10. 20 divided by 10 is 2. 30 divided by 10 is 3. X squared times x to the 4th. You got x to a power times x to a power. You add the exponents. 2 plus 4 gives us 6. And here we have y to a power over y to a power. Subtract a smaller exponent from a larger one. 12 minus 3 is 9. And we're going to have y to this power, y to the 9th power, where our larger exponent was, which is up on top. And that would be our answer. And I think that was the last problem. Yes, it was.